Guys, good morning. Been a funny little day of tech issues here, but we'll deal with it. So, today, in your notes, you can pre print these out as you see them. So, like I have them all handwritten, pre printed out. You can print out the blank copies from the note chapter, and then you can fill in or you can take notes separately. So, we'll kind of move through this today, and then I will throw some Edpuzzle stuff at you guys in a few. But we're having a few technical difficulties today. So here we go. So, chapter one, introduction, we're analyzing categorical data. So, if you want to, you can read pages 2 to 4 because I'm pulling everything right out of the book for you guys because there's no online resource for you. So here's the idea. Individuals are the objects that are described in the data set, and the individuals can be people, places, things, animals, doesn't matter. The variable is a characteristic of that individual. It could be height, weight, anything, how fast you run, how long you drove, how long it takes in the drive through. There's all sorts of different pieces. So what we want to do is we want to focus on who is being measured and then what is being measured. So who is being measured is the individual, and what is being measured is the variable. So as we move along, the idea is that you can break these into categories or groups, and if you can use and do that, they're usually words, like it says right here. They're usually words, and I'll show you some examples. But they can be numbers, and I'll show you some examples of that. But it's usually categorical means they're broken into groups or categories. Like an easy one to explain to you guys is either a male or female. Those are really straightforward categories. And then you can make counts with that or do whatever what you need. Values of quantitative variables are usually measured in numbers, like time taken to eat a hamburger. That's a number. And that's usually a quantitative variable because you're looking for the average or different things like that. So we're usually dealing with numbers. All right, let's move down a little bit. All right, so the types of data that determines what kinds of graphs we're going to use. Make sure you understand it's going to pay off later to learn the types. Categorical and numerical graphs have different displays, and so we want to make sure that we understand which one's which. So we're going to get used to that right now. Some of these scans are a little bit iffy, so if they are, sorry about that. Let's see here. So categorical variable, it places an individual into groups. We talked about that. This is the definition right out of the book. So we ever use my brain just went dead. Numbers. Do we ever use numbers that describe a categorical variable? So if we look at this, the idea is an area code. Because if we look at the state of California, and I draw a real quick state of California here, right? There's my state of California. And we're 559. That breaks us up into the middle of California. That's our 559 area code. Above us is the 209 area code. Below us is the Bakersfield area code, 661, I think. So I'm from the original 805 area code over here. So area codes break us into categorical value, and it looks to divide the distribution into categories. So yeah, we can use numbers. All right. So what's another example like area code? So that's your next stop when it comes to Edpuzzle there. You might have seen it prior to that. It was zip codes, prefix, age, categories, letter grades. Often that it requires quantitative variables like age and stuff like that are going to be broken up into categories. So something like age 0 to 10, and then 11 to 20, right? And then 21 to 30. Those are now ages, their age that can be broken up into categories. So that's usually by range is how they divide those into categories. And so there's always a kind of one of those ideas where you have to look at what they're asking you, and are they breaking it into groups? Are they asking you for percentages? Are they asking you for averages? Because if you understand that piece, you understand that if they want the percent of people that are from 0 to 10, they're probably dealing with categories. But if you want the average height of people or the average age of people, once we work with average, we're now all of a sudden dealing with quantitative. So that makes it a little bit different when it comes to distinguishing that. So it's all what they're asking you guys. Okay. Uh, do we ever use numbers to describe values in the categorical? Yeah, we keep saying that over and over. Height is a number, it's categorical though. Language spoken is categorical. So we have some different ways that we can look at it to show that the categorical values can be recorded as numbers. All right, so let's move down to the next piece. So the idea is this: you're given the census data. There's 10 randomly selected individuals, and you want to be able to say, okay, who are the individuals in the data set? Before you answer that piece, make sure you understand the format of tables before you kind of look at it. The rows are individuals and the columns are the different variables. Okay. So the rows are individuals. So after you answer that piece, the individuals are the 10 randomly selected individuals, which comes from this up here on the top right here. So it comes from that right there. All right. So they're the 10 randomly selected individuals. So what variables are measured? You guys can't see it really well. This is one of the tech issues I'm having. There's one of the programs isn't working, so I'm having to kind of mess around with this. So, what are the variables measured? And then break them up into categorical and quantitative, and then what units are they? So I'll give you a little bit of time on Edpuzzle. If you have these printed out, you'll be able to see the question a little bit better. But answer that for me real quick. And you should have something that looks like this. You should have categorical. Sorry, guys, my phone's going off in the background. You should have categorical, state, gender, marital status. Quantitative is the number of family members, age in years, total income in dollars, travel time in minutes. Notice how it's mostly numbers, and those will be quantitative. So that's kind of the idea behind it. So here's the next piece of it, and that's we're on to pages 5 and 6 now. Read pages 5 and 6, follow through. The idea is this: it's a distribution. This is a big term for you guys. It's basically the distribution of the variable tells us what the values take. In other words, how often it becomes a value, and then what does it do, or what they mean by what does it take. How are we reading them? Are we reading it as height? Are we reading it as a range of height? So there's different ways to look at that, and we're technically almost always going to use some sort of chart or some sort of graph. And we use those to make inferences or summaries. And this is where statistics starts becoming a bigger part of what we do, is that we're always making inferences and summaries, and it's easy to do it visually. Visually is a great way to do it. So in your book, you can have a better example of this, but it says display the distribution of a gender and the distribution of a number of family members for the sample. Make sure you emphasize your labels really well, like I've done here. I got male, I have female, I have the number of citizens. And then bar chart would be great for gender, and then dot plot for family members. So a bar chart is very clear. There are 6 females and 4 males. Now, if we look at this, and I should have done a little bit of a better job here. So this is I'm good. Number of family members. So we have 1 individual has one family member. Two individuals have two family members. Two individuals have three family members. Four of those individuals have four family members. And then one individual has six family members. So we could say the most common family member is four. Number of family members is four. So we're actually looking at this, and it's really easy to see and do things like that. So we have now, what is the difference between a data table, a frequency table, and a relative frequency table? Well, tables are tables. This is a data table here. This is a data table here. And then these two are new data tables. And these are these are used quite frequently when it comes to statistics. So using communication and context. In other words, context is the key to everything. So whenever you're dealing with stuff, make sure you're dealing with context. Like we know that this is the number of citizens, male and female. It's out of context of the problem. So data table lists each kid in a row and separates in columns. So if you look at page 4, you'll see what I'm talking about. Frequency tables summarize one categorical variable using counts. So the data table lists everything and anything. So this up here is a data table. It's got all sorts of stuff on it. This is also a data table. It's not as much, but it's more of a distribution. Now, when you get down to here, we are looking at, I'll just go to the examples here. Data tables include all the tables that display data in columns. So that's what I was talking about earlier. Now, here's a table. This is a frequency table. It just includes counts. So in other words, adult contemporary, by the way, this is on page 8. So if you want to look at it on page 8, I just drew a couple of them. Adult contemporary music, 1,556 stations. Adult standard music, 1,196 stations. And then it keeps going and listing out all the different ones. And at the very bottom, it lists the total 13,838. So now, if we're looking at that, it's just displaying data. It's counting data. That's what a frequency table is, telling us how many times something comes up. Now, if we look at relative frequency, it turns it into something that's useful. So we take the adult contemporary, and if you look at the chart, it says the percent of stations is equal to 11.2%. Well, 11.2%, they get that by taking the total count for adult contemporary, which is 1,556 from right here, and they divide it by the total number of stations, which is 13,838, and they get 11.2%. That gives us a little better idea because that tells us that's 11.2% of a total of 100. This doesn't give us as much information. So relative frequency tables make it out of 100, and they make it easier to understand and see. Sometimes this number, 1,556, doesn't mean anything. The 11% gives you a little better idea. So we're going to go talking about pie charts. So here we go. I didn't have anything useful, so I made a pie chart. The pie chart. It must be true because it's a pie chart. I pledge my life and fortune to the pie chart. So pie charts are nice and neat, but they're not what we need to be doing. The most important thing to remember when you make pie charts and bar charts is proper labeling. Proper labeling. The idea behind it is that you need to display so you can make assumptions. So if you look at the bar graph and the pie chart on page 9, you'll notice that it's much easier to see the data with the bar graph. Okay, I didn't want to write it all up here, and it would just take too long. So if you look at page 9, I'm going to work on some things like that and see what we can come up with a little differently in our notes. So when is it inappropriate to use a pie chart? When there's not 100%. It has to be percentages. Bar chart does not have to be percentages, but remember, pie charts always have to be percentages, and you always have to have 100%. Pie charts are rarely used, so don't even worry about it. So if we look at this piece right here, make a bar chart for the data above, and I will let you guys do that and try to upload it onto Edpuzzle. and then we will move from there. Uh, I'll pause it right now. Let's see if I can pause it. It's a good spot. Let's see what I can do. All right, guys. I see if this works. I paused it there. We'll see if hopefully it works. So you guys are making a bar chart. So what are some common ways to mislead a graph? Here's another thing. I want you guys to make an assumption of the percentage of each of these. So just look at the picture. What's the percentage of each of those? Uh, and so it's the percent of market share. And this is a Macintosh ad. So if you look at this, this is the actual percentages. There none is 17%, 12% is PC, and 71% is Mac. And if you look at this piece right here, there's no way. This is like almost double of that. So right now they're kind of cheating in the fact that they're not making it look correct. And then this is way bigger than this. And if you said it was like 10 times bigger, if you did the math, it'd be like 10 times bigger. That means this is 120%. So you got to watch out, especially for you guys, social media, ads, different things. They're famous for cheating the system there. So that's the basic idea behind this first section. It's just graphing different things and doing different stuff with them. Sorry, it was a real quick, but like I said, my technology wasn't working and I wanted to get you guys going on the first part. So we'll make it work.